This video is one amongst a series of videos in which I take up examples to examine how to reduce a fraction to its lowest terms or to its simplest form. The example I will take up in this video is 167 over 1837. We need to find out the common factors between 167 and 1837. Instead of examining each prime number starting from 2 to see if it is a common factor, I will find out the prime factors of one of the numbers and then see if any of these factors divides the other number. It makes sense to take up the smaller number 167 and prime factorize it. Let us do that. 167 is odd, so it is not divisible by 2. Let us try 3. 1 plus 6 plus 7 equals 14, which is not divisible by 3. So 167 is also not divisible by 3. Next number to consider is 5. 167 doesn't end with 0 or 5, so even 5 is ruled out. Next is 7. Let us try to divide 167 by 7. 7 times 2 is 14. 16 minus 14 equals 2. I bring down the 7. 7 times 3 is 21. 27 minus 21 gives me 6. We get a remainder, hence 167 is not divisible by 7 as well. Next factor to consider is 11. Let us apply the divisibility test of 11. I will write down 167 again. Now starting with the units digit and moving towards the left, I will take alternate digits and sum them up. 7 plus 1 gives me 8. I do the same thing starting from the tens digit and moving towards the left. This gives me 6. I take the difference of these two numbers. 8 minus 6 equals 2. This is not divisible by 11 and hence the original number 167 is also not divisible by 11. Next number to consider is 13. But should we even consider it in the first place? For answering this question, I'll write down a few entries from the multiplication table of 13. I'll start with 13 times 9, which equals 117. 13 times 10 equals 130. 13 times 11 equals 143. 13 times 12 equals 156. And 13 times 13 equals 169. I'll stop here. We don't see 167 here, and so we can be sure that 167 is not divisible by 13. But that is not the reason I wrote down this table. The reason I wrote down the table will become clear if you look at a few of the multiples of 13 from this table. Say 143. 143 is 13 times 11. So obviously 143 is divisible by 13. But then 143 is divisible by 11 as well, since 13 times 11 is 143. If we were examining factors for 143, we would have come across 11 first and found that it is a factor. Let us look at another multiple of 13, say 156. 156 is 13 times 12, which we can write as 13 times 2 times 2 times 3. Clearly, we would have come across 2 and 3 as factors before we reach 13. Now, coming back to our number 167. 167 is less than 169. So, if at all 167 was divisible by 13, it would be 13 times some number less than 13. And that number or its factors would have already been found out earlier. Hence, it doesn't make sense to check if 13 is a factor. So when exactly do we know that we don't need to check any more prime numbers? Clearly, when the prime number we are considering times itself exceeds the given number, we can stop. 13 times 13 is 169. 169 is greater than 167 and hence we stop. We were not able to find any prime factors for 167. Hence 167 is a prime number. So all we need to do is to see if 1837 is divisible by 167. Let us do that. 1837 divided by 167. 167 times 1 gives me 167. 183 minus 167 gives me 16. I bring down the 7. 167 times 1 gives me 167. 167 minus 167 gives me 0. There is no remainder, and hence 1837 is divisible by 167. Hence 167 is a common factor between the numerator and denominator. Let us divide the numerator and denominator by 167. 167 divided by 167 equals 1. And 1837 divided by 167 gives us 11. And we are done. 1 over 11 is the equivalent fraction in its simplest form. In this video, I took up an example where the numerator happened to be a prime number and examined a technique for finding out that it's a prime number. If you have any comments or suggestions, you can leave them in the comment section. Also, please consider subscribing to my channel for more such videos. Thanks for watching.